Until recently, only university students, companies, and countries built satellites. Today, even young children, as young as 12, are building small satellites launched by NASA into space. Hello, I'm Kevin Simmons. I'm an educator in Palm Beach Gardens, Florida, the founder of Blue Cube Aerospace, and the principal investigator for 2 satellites through NASA's CubeSat launch initiative. Our presentation today will focus on the first 5 years of the Wolverine CubeSat development team. We employ a blue sky learning mentality, which focuses on achieving ridiculously difficult aerospace goals by embracing a growth mindset. And we do this by designing, building, testing, and launching small satellites called CubeSats. A CubeSat is a disruptive nanosatellite form factor that's based on a unit of 10 by 10 by 10 centimeters cubed. 20 years ago, CubeSats were created to provide graduate students a chance to design, build, test, and fly a satellite in the time they were at the university. Today, this disruptive technology has radically changed the way we view the Earth, the way we validate new technologies, and the way we conduct basic science. For my first group of students, we began with a singular vision statement: to design, build, test, and fly our satellite within 3 years. And we did accomplish that goal in just over 3 years. In addition to building satellites, one of the strengths of our team is the seamless integration of both the technical and the soft skills to merge creativity and expertise. We purposed to prepare students not only to do the remarkable, but to be very competent in sharing their work at the highest levels. Thus was born the Techies and the Talkies. I will now introduce my colleague and team member, Finley Strauss, to share more about the Wolverine CubeSat development team.
At Blue Sky Learning, we know how important it is to encourage a growth mindset. Children must try and try again and never give up. One thing we found out that is so crucial is to motivate children. Because if a student is achieving things, then the student believes their talents can be developed, meaning they are now highly motivated. Blue Sky Learning allows for deeper understanding by strong alignment to real-world student work, which again ties into motivating students, produces greater educational outcomes. Something that connects this as well is co-opetition. Co-opetition means that student and student teams compete at times, but learn to collaborate and communicate at other times by creating our own mutual goals and then achieving them. Founding the WCDT. On August 25th, 2015, we had 9 incredible students who had a goal. And that goal was to design, test, and fly a CubeSat in just 3 years. We had many things to do, such as establishing a white school hardware heritage, collecting low Earth telemetry, and then validating a novel payload in a 1U student-built CubeSat and more. First, we began creating chassis and emulators. Next, we used a Python-based code, and we were rewarded with being able to launch an HAB, also known as a high-altitude balloon, using RPI emulators and more. More about our HAB missions. Our first HAB was launched in April of 2017. It was an 8-foot in diameter balloon with an iPod 4 to receive data. We had a global star telemetry sensor, and we had live video to our ground station. Using a similar method, our second HAB was April 2018. And this year, with new students, we plan to launch our third one. The YSAT-1 is a 1U CubeSat with an NSL fast bus structure. We collected in-flight telemetry, and we are the first middle school ever selected through NASA's CubeSat launch initiative. Our CubeSat was testing extremophile bacteria in space. On our CubeSat bus, we had dual microcontrollers, which were 20 bytes per data sample and pass from it to the bus processor in a hexadecimal format, and stored in non-volatile memory and transmitted to the ground through Globalstar. Next up is my colleague, Ava Patterson.
The payload the YSAT-1 examined was extremophile bacteria in low Earth orbit, using fluorescent dye to show whether the bacteria was dead or not. YSAT-1 validated a microbiology novel lab-on-chip system designed by NIRAD Inc. The bacteria was thawed, hydrated, stained, and illuminated. The blue LEDs caused the bacteria to fluoresce, correlating to state in cells. When the bacteria fluoresced green, the bacteria was alive. When it fluoresced red, the bacteria was dead. The photodetectors counted the flashes of green or red, and the payload processor sent the data to the bus processor for later transmission. The students of the Y School are involved in every step of creating and launching the CubeSat, From the mission start date in 2015, the students at Weiss worked diligently. In 2017, Weiss selected by the CSLI and began working on the certification requirements. True to the Blue Sky learning philosophy, the students at Weiss were involved in every step. We received FCC approval for an experimental license on the 13th of September, and integration with the Spaceflight Industries in Seattle on the 30th of September. The WISeSat-1 launched from Vandenberg Air Force Base on December 3rd, 2018. The WISeSat-1 had a nominal deployment from the Spaceflight Industries Free Flyer. It was launched into a polar, sun-synchronous orbit with an apogee of approximately 575 kilometers. The WISeSat-1's data was relayed to us from Globalstar on a dashboard created by Near Space Launch. Of the 16 proposals selected nationwide in the 10th round of NASA's CSLI, the CubeSat-1 was selected as the only K-12 entity. Our next project is the CubeSat-1 team, which also emphasizes the Blue Sky learning philosophy. This team originally consisted of 3 7th grade students and a teacher. The students proposed the mission statement, estimated the cost of the hardware by interacting with component vendors, and are drawing on the significant experience of the WISeSat-1. Once one of our proposals is selected, a Wolverine and Wolfpack students engage in the CubeSat mission. Using NASA's Space System Engineering Handbook, we completed the mission concept review. We will continue to be involved in every step, creating an invaluable hands-on experience, applying creativity and critical thinking, and learning project management skills. This next WCDT mission is the development of the AMARIS Lunar Rover, with deployment in 2023. The Lunar Rover is based on NSL's CubeSat technology and Astrobotics peregrine landers providing the delivery of the Lunar Rover and telemetry. Our current proposed lunar landing site is Lacus Morcus, or the Lake of Death. Our goal is to apply as much knowledge as possible from the students' WISeSat-1 experience to the Lunar Rover project. Up next is my colleague, Ella Shooter.
The WCDT, more known as the Wolverine CubeSat Development Team, wants to help NASA reach their goal to have a CubeSat launch from all 50 states by reaching out to North Carolina and Nebraska to help them send a CubeSat into space. We're partnering with Johnston County School System in North Carolina and with the University of Nebraska. We are trying to submit our proposals by the fall of 2020. A lot of students at the Weiss School enter space settlement design competitions. In 2019, we even traveled to China to represent the U.S. in the International Future Space Scholars Meet competition. We were also 8th grade world champions in the National Space Society Space Settlement Design competition in 2020. We also attended the SmallSat conference, where the Wolverine CubeSat development team was able to meet with Dr. Carey, MIT's CubeSat professor. We competed in the University Poster event in 2019 and 2020, and presented in 2018. After working with the WISeSat-1 since 2017, we just sent in our final report, which consists of a summary of all technical and educational accomplishments we have completed since the beginning of our CubeSat journey. The report is 99 pages long, and we had 31 students and teachers selected to make technical papers, conference presentations, exhibitions, and university poster competitions. We have competed and contributed to multiple national and international events. The Wolverine CubeSat development team has participated in so many events over the year, and we've won a lot of them. In 2017, we were the first middle school selected for NASA's CSLI program. In 2020, we completed our first satellite mission with NASA and just submitted our final report. We plan to launch our second satellite with NASA in 2021. All students that participate contribute in their own way, but most of the older students work on more of the bigger projects, such as the Coloring Book, Miss Lear's Banquet, the Tallahassee Trip, the Stellar Explorers, the AIAA Blue Origin suborbital flight. All the Weiss School students also compete in the Science and Engineering Fair. Most of the students that participate go to the regional fair every year. We were the most awarded school during a 5-year period for the Science and Engineering Fair. All of our early goals as Wolverine CubeSat development team was determined by students. Some of these goals were conducting CubeSat emulator captive carry flights, tethered balloon sat mission, and we attended the SmallSat conference in Logan and more. Thank you.